All right, let's talk about a huge problem in our digital world, deepfakes. Specifically, why do the tools we build in labs to catch them, well, why do they seem to fall apart the second they get uploaded online? Today, we're diving into some really fascinating research that points to a hidden culprit and, even better, a brilliant solution.
I mean, it's the big question, right? We have these super sophisticated AI models that can spot a manipulated video with incredible accuracy, as long as it's in a controlled lab setting. But the moment that same video gets posted on social media, that accuracy just plummets. So what's going on? What is happening in that simple act of uploading a video?
Now, your first guess might be that deepfake tech is just getting too good, too fast. And that's definitely part of the story. But the research we're looking at today shines a spotlight on a different, kind of unexpected accomplice in this whole mess. And it turns out the hidden enemy is the very platform where the deepfake is being shared. We're talking Facebook, YouTube, TikTok, you name it. See, these platforms aren't just passive pipes for content. They actively process every single video you upload. And that process, it changes everything.
The researchers have this fantastic term for it: compression laundering. Think about it. To handle the insane amount of video uploaded every day, platforms have to compress those files like crazy. It saves them a ton of money on storage and bandwidths. But a side effect is that this compression acts like a digital bleach, wiping away all the tiny, subtle artifacts, the forensic fingerprints that our detectors are trained to look for. The evidence literally gets laundered away before our digital detectives can even get to the scene.
And this comparison right here shows you exactly what I mean. On the left, that's the original deepfake. It's not perfect. It's got those little digital seams and weird inconsistencies that a good AI can pick up on. But look what happens after it goes through the social media pipeline. The video on the right, those crucial fingerprints are just gone. They're either mangled or totally erased, making the deepfake look just like any other heavily compressed video.
So this creates a massive headache for researchers. If the problem is social media compression, the solution seems pretty simple, doesn't it? Just train your AI on videos that have already been compressed. Easy. Except it turns out it's way, way harder than it sounds. There are some serious real-world roadblocks. For one, platforms don't just let you download millions of their videos. Their APIs have super strict limits. Even if you could, getting that much data would be incredibly expensive. Then you've got all the privacy rules and data sharing constraints. And to top it all off, the platforms are constantly changing their compression algorithms. So even if you build the perfect dataset today, it could be totally obsolete in a few months. And this quote from the researchers themselves just nails it. There's this huge gap between what works in the clean, controlled lab and what works in the messy, chaotic, constantly changing real world. A detector that's practically perfect on a clean dataset can become almost useless once it's out in the wild. So if you can't get your hands on a mountain of real-world data, what do? Well, this is where the research gets really elegant. Instead of trying to get the data, you build a virtual mountain. You create an emulator that acts just like a social network. The process they came up with is just so smart and simple. Okay, step one, you upload just a small batch of videos to, say, YouTube. Then you analyze how those videos were changed to figure out the platform's unique compression signature. Step two, you use that signature to build a tool on your own computer that does the exact same thing. And finally, step three, you can now process millions of videos locally, creating the perfect, realistic training data without ever needing to ping the platform's API again. And that's the breakthrough right there, in one sentence. That massive bottleneck of getting data, it's gone. Researchers are no longer dependent on the whims of these big platforms. They can generate a basically endless supply of realistic training data whenever they need it. Of course, an idea is only as good as its results, so the researchers had to prove it. The big question was, does a detector trained on this emulated data actually work as well as one trained on the real deal? This chart pretty much tells the whole story. So that first bar on the left, that's the standard lab-trained model trying to detect deepfakes on social media. Its accuracy is low, just like we'd expect. The bar on the far right, that's a model trained on a ton of expensive, hard-to-get real social media videos. Its accuracy is high, but that's the method that just doesn't scale. But look at that middle bar. That's the model trained using their emulator. Its performance is nearly identical to the one trained on real data. That's the proof right there. It absolutely works. And this wasn't just a one-off thing. They proved this method is solid. They tested it on the standard Face Forensics++ dataset. It worked on videos from Facebook and YouTube from way back in 2021, and it still worked on videos from 2025 across those platforms and newer ones like Blue Sky. This shows the whole framework is robust and can adapt.
Okay, so this leads to a super practical and important question. For this whole thing to be truly useful, you can't need to upload thousands of videos just to build the emulator in the first place, right? So what's the magic number? How few videos can you get away with to build a good one?
The answer is actually kind of astounding. It's 30. Just 30 videos. That's it. By uploading and analyzing just 30 videos for each resolution they wanted to test, the researchers could build a stable, reliable, and accurate emulator for a platform. This makes the whole approach not just effective, but incredibly efficient. Any research lab can do this.
So let's just tie this all together. What's the real impact of this work? Well, it's about finally closing that massive gap between what we can do in theory and what actually works in practice. At the end of the day, this isn't just a cool academic paper. It's a blueprint for a real tool. It gives developers a scalable and practical way to build deepfake detectors that are actually tough enough to survive on the real internet. This is a huge leap forward in our ability to fight disinformation where it spreads the fastest. And that leaves us with one final thought to chew on. This emulator is a powerful new weapon in our arsenal, but the battlefield is always shifting. Platforms are going to keep updating their systems, changing their algorithms. This research gives us a way to adapt much more quickly, but it really just highlights the constant cat and mouse game at the heart of digital trust and safety. The race is definitely on.